Hello, this is Adam Betts, and today I am going to be covering how to think like a computer programmer, question 13 in chapter 6. And to do so, we need to write a function, slope, x1, y1, x2, y2, that returns the slope of the line to the points x1 and y1 and x2 and y2. It also needs to use that function to determine the intercept, which is the y-intercept of the line that goes to those points. To do so, we're going to use some test functions here. And to do this, we're going to import a test module from Python, and we're going to define a test right here with tests and if it did pass. And basically, it's going to print the result. What this does is if the line comes out true for the statement, if this is true, it will say, hey, it's okay. If it's not, if it comes out false, it'll return failed, which is pretty handy when doing testing functions, since this has a predetermined output and it lets us know if it actually works appropriately. So first, we're going to pull in these tests for these functions, so we don't have to pull those up again. And I'm going to comment out the second part for now, because we'll come back to that a little bit later. So first, we're going to take this one at a time. We need to define a function slope. So to do so, we're going to define slope. We're going to do x1, y1, x2, y2. And what this does is this names our function, as we know. And we need to actually design some code. Well, to find the slope of a function, it's pretty easy. I'm going to use the equation editor here in Microsoft Word to do this. And we know that slope, or we can also call this m, and our form is equal to the y1 minus y2 divided by x1, or x sub 1 minus x sub 2. What this does is this is our formula for it. Using this, we can actually define our function using this exact same setup. So we can go that slope, and we can just call this slope if we want, equals, well, we put this in parentheses, so we got our, and I just noticed a quick little quirk here, and make sure that's a 2. So, and it really doesn't matter the order, because if they're both negative, it comes out positive. So really, as long as they're in the same order, if we're doing this, so we're going to do y1 minus y2 divided by x1 minus x2. And we're going to return our slope value to make this a fruitful function. And we're going to test this, and we're going to call this our YouTube for 6-13. And we're going to see what happens. Well, we see that the test comes out okay for all of these values, meaning that this first part of the question is done. So we don't return this every time. We're going to comment this back out with Alt 3, and we'll uncomment this with Alt 4. And we're going to move on to the second part of this question, which is to do the intercept function. Well, so we're going to define our intercept, and we're going to be calling the same values, x1, y1, x2, y2. And we're going to need to find the function. Well, now to find an intercept, we need to go back a little bit. So we have our slope function here, which is handy. And using Alt equals in Word, you can bring up equation editor, which makes it a little easier to look at. We know that y equals mx plus b, where our m equals slope. Our x and y are just that. They're just a point x and point y. And our b is equal to our y-intercept. So to get this correct, we're going to need to find something that gives us our intercept. Well, b is our intercept, so if we rearrange this equation, we know we can go y minus mx equals b. And there we go. That's how we're going to find our slope. Meaning we take y, which can be y1, and x is x1. It has to be equal to him to plug in this, and it'll give us our formula. So using that, we can go that our intercept, and we can just call this the same thing, equals slope mx was b. Well, we know what our slope's going to be, so we can actually use this slope function and go slope x1, y1, x2, y2 minus times mx, which is going to be an x value. So let's just use x1, and that should give us this right here. So y minus mx. So we need to go, this is our mx, and let's just go and keep this in our y1 minus, and just put this in parentheses to make sure it's right, and return intercept. And we're going to see if this actually works. And it does. So what we have done here is we have used this slope function as a helper function, and we had to call it up these values, and we used 2 of the x coordinates, since you need all of these to determine the slope. And this is showing that, if the coordinates are 1, 6, and 3, 2, that your intercept is going to be 3, and the slope was automatically calculated through this, so we don't even have to worry about what the return is, and it just gives us that. So ultimately, this is a pretty straightforward problem that just requires a little bit of basic knowledge of algebra and some manipulation, and you get your answer. And it gets pretty easy. I mean, always make sure to comment out your code, so we know its slope. It returns the slope of a line that passes through points x1, y1, x2, y2. That way, whenever someone calls up the function, they can tell what it is. And the same thing here. And there we go. And now we have a full code. And by utilizing the system module in Python, we defined a test parameter to make sure that these work, and these were given values so we can actually check our function. It's always important to actually know what the answer is to what you're trying to solve, because the purpose of this is not to answer one question, it's to answer any question that comes your way. With that said, this is Adam Betts, and hopefully you have a great day and learn something new.